Alright. Not here. So, you're right. We're going to look at global and local max and min, but before we do that, I'll practice this and then we can talk about what I mean by global versus local max and min. So the first thing we need to do is determine our stationary points. How do we find a stationary point? Derive it, so I need to derive my function dy dx, and that should give me that. What do we do after that, Jet?
Oh, I don't know that part. What happened to the 3 that was on the bottom of the x?
I multiplied the 3 down,
So why isn't it?
3 down, maybe.
because 3 divided by 3 is 1.
Oh, I think it's times.
Take the power down,
Yeah.
take 1 off the power.
Oh, okay. Oh, so you haven't arrived yet. Oh, you have.
Yeah.
But then would it just be 2x take 4x plus twice?
No, it's 2 times 2, x. Alright, I've obviously gone one step too fast, we'll do this again.
Oh no, yeah, that was it.
Are we happy with that?
Yeah.
What do I need to do? I need to let this equal
0.
0. Why does that tell me where stationary points are? Because the derivative tells us about the gradient of the tangent. And when we have a turning point, the gradient of our tangent is 0. Horizontal line. Cool? So because I let that equal 0, I now have to do what? Factorise. I've got a quadratic, so I need to factorise. This is not going to work.
You only need quadratic.
Yeah, I need to make that negative 5. Oh, that affects your answer, fellas. I mean, Ethan's on his laptop, so I don't know how his answer's going. Maybe pop that one down. That makes that x minus 5, x plus 1. Thanks, girls. It's very good that you can identify what I should have done with my question before I can. It's actually impressive. You were about to say that too, weren't you, Nick? Obviously, okay. So for that to equal 0, either that must equal 0 or that must equal 0. Cool. Can x be negative? In this situation, can x be negative? Yes, it can be. Trick question. X can be negative because we're not dealing with time or length or anything like that. There's no context to the problem, it's just a function. So x can be negative in this context. Cool, I'm done, right? What do I have to do? Before that, I'm doing A first.
Oh, see if it's upside down.
See if it's a max or a min. How do I do that? I need a table. So I draw my table up. Now this is, alright, we're going to do a pro tip here. I could do 2 tables, or I could do 1 table with 5 columns. Or 6 columns if you include the title. What should I put here? 5. What should I put here? What should I put here? What should I put here? What should go there? 0. Pick a number between them. Which is the easiest number to deal with? 0. Now all I'm doing with those x values is what? Shoving them back into that equation. So I'll give you 20 seconds to fill out the table while I do the working over here.
So do you sum it back
into that.
Derivative.
one on the left.
Into the derivative function to start with. What's that? That's okay, that's all right. Thank you, that's good to know. Put it up there. So once I've got these values, I've derived each of these individually. I've got 7 for the first one. I've got -5 and I've got 7. Do I care about the size of the numbers? All I care about is there. What do I care about? Whether they're positive or negative. That's what my function looks like, correct? So what does that tell me about this point here? That point there is it's a mass. If only I had a kid in the class called Min.
So why don't you put -2 where the x is?
Why?
Yeah.
I just picked a point that was smaller, less than -1. I could have put -3, I could have put -5, doesn't matter. Cool? And this point here is min. Sweet. Now what I want you to do is do your key features, so find your key features and check that on the graphics calculator, and then I'll come back in about 2 minutes to talk about global masses and global mins.